Welcome back to section 4.1. This is part 2. The procedure that we would use for solving these inequalities is to simplify the algebraic expression, if possible. Collect the variable terms to one side and the constant terms to the other, maybe combining like terms if needed. Isolate the variable and solve. Flip the inequality when multiplying or dividing by a negative number. And then express the solution in both interval notation and a graph on a number line. So what does that mean? Well, example 1, solving this inequality. 3x minus 5 greater than negative 17. So we need to move over this 5. We would add 5 to both sides. Gets rid of that 5. Well, if 3x is greater than, this would be negative 12. And then dividing by 3 to isolate that x. These cancel. We get x is greater than negative 4 in this case. So as an interval notation, as we had seen, smallest this is negative 4. It goes up towards infinity. And because this is just a greater than, no or equal to, it is surrounded by a parentheses. And the graph for this would look something like this. We have negative 4 and an open circle because it's not included, and being shaded towards the right, as we can see. But something a bit more complicated, solving this linear inequality, writing the solution set in interval notation again, and of course graphing it. 8x minus 9 is less than or equal to 6x minus 10. So to move these terms over, we can first subtract 6x. These cancel. We have 2x minus 9 was less than or equal to negative 10. Then adding 9 to both sides. Again, these cancel. We get 2x is less than or equal to negative 1. And then finally divide by 2. These cancel. And we are left with x is less than or equal to negative 1/2. In interval notation, this highest this could be is negative 1/2. And we keep going down towards negative infinity. Of a parenthesis on this side and a bracket on the other. The graph. We have negative 1/2 here. We would have a closed circle at negative 1/2, and we would shade to the left. Well, my third example of this, a bit more complicated. We want to express this solution set in interval notation, and then graph the solution on a number line. Since we have all those fractions, let's multiply by the least common denominator for this, just to clear them all at once. For 6, 9, and 2, that would be the number 18. So multiplying the left and the right by 18. Okay, so going in order. Left side here would be 18 divided by 6. That's 3 times x minus 8. It's greater than or equal to 18 divided by 9 is 2 times x minus 4 plus 18 divided by 2 is 9. And then distributing to simplify this a bit, 3x minus 24 is greater than or equal to 2x minus 8 plus 9. We can combine like terms there on the right. This is 3x minus 24 is greater than or equal to 2x plus 1. And now we can move x terms and constant terms. Subtract the 2x from both sides. These cancel. x minus 24 is greater than or equal to 1, positive 1. We can add 24 to both sides to isolate this x. And we are left with x is greater than or equal to 25. As a number line, starts at 25. We would have a closed dot on 25 and shade it to the right. And then in interval notation, this would be a bracket, 25, and then positive infinity. But sometimes, just like with equations, we could have unusual solutions to these. We could have no solutions. This is where the inequality is false for all real numbers. All real numbers. This is where the inequality is true for all real numbers. So for example, number 4, we want to solve this linear inequality and graph the solution set on a number line. So for 6x is less than 6 times x minus 7, we could distribute the 6. We get 6x is less than 6x minus 42. And then subtract 6x from both sides. These cancel. We are left with 0 is less than negative 42. But 0 is not less than negative 42. It's greater than it. So this is one of those no solutions. So we would express this as a circle with that line through it for that no solution. And graphing it in a number line would just be a blank graph, since there's no solution. For example 5, we have solving this linear inequality and graphing the solution set in a number line. 6 times x plus 3 is less than or equal to 5 times x plus 7 plus x. So distributing the 6 and the 5, respectively, 6x plus 18 is less than or equal to 5x plus 35 plus x. We could combine the x's on the right-hand side. So 6x plus 18 is less than or equal to 6x plus 35. And now we could subtract 6x from both sides. These cancel. And we're just left with 18 is less than or equal to 35. But we know 18 is less than 35, so this is true. Which means it is true for all real numbers. So in interval notation, that's negative infinity to positive infinity in parentheses. And the graph of the number line with 0 there in the middle would just be shading the entire graph with no dots open or closed in it for this. Let me know if you have any questions or concerns. This was part 2 of this, so be on the lookout for part 3. Thank you.